All right, grade 12s. So welcome to our revision session today. And what we're going to do is just cover topics that we have gone through here at Good, Better, Best, that we have gone, that we have finished, that we have put to bed. I must mention this though, last week I was, or actually this week, sorry, I was questioning, because I had a few people come to me and say that, yo JP, we've kind of finished this year GBB, but my school, they're only starting it. So I was kind of like, why am I, who only sees you guys once a week, why am I ahead of your schools? And I couldn't place it in my brain at the time, because my brain stops working after a certain time in the day. And I was like, I just couldn't for the life of me understand, why this is the case. And then out of the blue, I realized, oh my gosh, we started at GBB a week or two, I think, or maybe a couple weeks earlier than the schools, because I think COVID pushed us back a little bit, or pushed the schools back a little bit. And I think until February, some schools started in February. And we started at, or we started in January, I think. So we're a couple of weeks ahead. So unfortunately, yes, of course, I might be slightly ahead. But having a revision class today kind of allows the schools and I to kind of level out on content. Kind of level out, and also before end of term. So before term ends, I think on the 23rd of April, we will have finished a vertical projectile motion, for sure. And again, we'd have another revision on class on vertical projectile motion to also balance it out. So when you guys go back to school on holidays, I start immediately with, or I hit the ground running where the schools hit it from. So what we're going to do today is we're going to start with a November paper of 2018 by the National Senior Certificate. And 2018 was quite a good paper as well, for paper 1. I tutored in 2018 and I used this paper in 2019 for my classes. So a very good paper, quite familiar with it. We're going to skip question 1 and jump straight to question 4. So question 4 is your momentum and impulse question. Okay. Now remember, just because it's your momentum and impulse question, guys, doesn't necessarily mean they're going to ask you everything on momentum and impulse. There's no time for that. They have to structure it. So you have 115 marks in 3 hours. Okay? You have 3 hours, which is 180 minutes, and 150 marks. Okay? So it's almost a mark a minute. Almost. Okay? If you do a mark per minute, all right, then you have half an hour, obviously, to check your work, run through it, okay? But of course, that never is the case, okay? The time it takes for you to write, and blah, blah, blah. I can get into the semantics of it, but I'm not going to, okay? But question 4 usually is your momentum and impulse question, okay? How do I know this? I've seen papers for 8 years, all right? Or if I minus grade 11 and 12, if I minus grade 10 and 11, I've seen question papers for 6 years now. Okay, so I know exactly how they look. Okay, question 4 is always your momentum and impulse question, so know the structure of your exam paper. Question 2 is a grade 11 question, Newton's laws. Okay, it's a Newton's law question. Question 3 is your vertical projectile motion question. Okay, and then question 4 is your momentum question. So we're going to start here. Okay, initially, a girl on roller skates is at rest on a smooth horizontal pavement. The girl throws a parcel of mass 8 kilograms horizontally to the right at speed of 4 meters per second. Okay? Immediately after the parcel has been thrown, the girl roller skate combination moves at a speed of 0.6 meters per second. Ignore the effects of friction and rotation. First question, definition. Define the term momentum in words. Okay? 4.2. Will the girl roller skate combination move to the right or to the left after the parcel has been thrown? Name the law in physics that can be used to explain the choice of direction. Okay, 2 marks. Okay, there's one more question underneath. So, okay, so I will go until 4.4 and then we'll do 4.5 afterwards. The total mass of the roller skates is 2 kilograms. Calculate the mass of the girl. Nice question. 5 marks. 4.4, calculate the magnitude of the impulse that the girl roller skate combination is experiencing while the parcel is being thrown. So your answer for 4.3 will definitely count in your favor for 4.4. Right. We have 1, 2, 3, 4 questions to go through. We'll just read question 5. Without any further calculation, write down the change in momentum experienced by the parcel while it is being thrown. That's a beautiful question to play on your brain because it's got to do with question 4.4 as well. 14 marks. So because obviously 4.4 is how far I can go with getting this information, so we'll give it about 12 minutes for 4.1 to 4.4 and then another 2 minutes for 4.5. So let's go, let's do it on our own for 12 minutes and I'll see you just after 7 o'clock to mark. So 4.1 was define the term momentum in words. This is simple. Momentum is the product of the mass of an object and its velocity, or it is the product of an object's mass and its velocity. Okay, 2 ways of saying the same thing. Okay, taken exactly from the formula, P equals mv. P stands for momentum, m for mass, and v for velocity. 4.2, will the girl roller skate combination move to the right or to the left after the parcel is thrown? Name the law in physics that can be used to explain the choice of direction. So they don't ask us to state, they just ask us to name it and answer either to the right or to the left. Okay, I'll take answers. 4.2, anybody would like to answer the first part, which is either to the right or to the left? Anybody like to answer just that first part? Anybody?
To the left.
To the left, Suleika, to the left. Okay, thank you. That is correct, everyone. So the girl roller skate combination moves to the left. Okay, let's see why. Okay, let's just check if they mention which direction she's going. She just says she's moving in a smooth horizontal. She's moving on a smooth horizontal pavement. All right. Oh, there we go. She's moving to the right. Okay, so initially she's moving to the right. And she throws the parcel to the right. So where does she go? So she goes to the left after she throws the parcel. Sorry, I got mixed up with my words there. Okay, throws the parcel. She moves to the left because she threw the parcel right. That is correct. Okay. Anybody else like to name and state the law? Or sorry, just name the law that can be used to explain. Newton's second law. That's one of the laws. Okay. Yes. Anybody else have a different answer to Asha? She said Newton's second law. There is a law that exists in momentum. Anybody like to state that law? Or just name the law for me? Leon Williams, third law, yes?
Third law.
Okay, Newton's third law. Okay. If you said Newton's third law, yes, that is the most preferred answers according to intuition, as well as, if I remember the memo correctly, yes, it is also the most preferred answer. Newton's third law makes the most sense as well. For every action, equal, opposite reaction. Through the parcel right, I go left. All right? That's it. Okay, equal opposite reaction. Newton's third law. Newton's second law and Newton's third law is also acceptable, as well as the principle of conservation of linear momentum, which is basically the law of action and reaction. Okay, so those are the answers there. But the most preferred answer, so actually you are right, but the most preferred answer would have been Newton's second law. Third law, if you were going to say Newton's second law, actually, then you would have had to say Newton's third and second. Okay. 4.3. Calculate the mass of the girl. So, the mass of the girl for 4.3. This was 2018, paper 1, grade 12. Cool. And it's November. Cool. 4.3. So, we know the formula, total initial momentum must equal total final momentum. Okay, we know that. That's the law of linear momentum. Okay, so that means m1 v I1 plus m2 v I2 all equals m1 v f1 plus m2 v f2. Quite awesome. Okay, so let's go have a look at the question again. She throws a parcel. Initially, a girl's on roller skates. Initially, a girl on roller skate is at rest on a smooth horizontal pavement. That first line plays a major factor in answering 4.3. Okay? She's at rest. Okay? It doesn't really matter what you think. She's at rest. Okay? Then she throws a parcel. Right? Immediately after she's been thrown, then she only moves. Okay? So, safe to say that this whole side here, okay, this entire side here is equal to what? Everything is equal to what? Give me a number. Remember, initially, she's at rest. You at rest?
So 0.
Thank you. That's what I want to hear. 0. Okay? Entire side is equal to 0. So we have 0, and that's equal to m1 v f1 plus m2 v f2. Now we got an equation we can work with. Okay? Cool. So, let's check it out. Question again. Now, the girl throws a parcel of mass 8 kilograms. Okay, so I'm going to make my parcel m1. So I'm going to say, well, that's 8 kilograms. And I'm going to check what was the she throws it at a speed of 4 meters per second. So 8 times 4. If you made it v2, doesn't really matter. Plus m2 is my girl, or the girl roller skate combination. Okay, m2. So let me state that m1 equals 8 kilograms. Remember, this is parcel. I'm putting that in brackets. m2 is the mass of girl plus roller skates. So not the mass of the girl alone, the mass of the girl and roller skates. Okay, m2. And after she throws the parcel, she goes to the left. So she throws it to the right, so that's forward, that's positive. So to the left means direction I need to indicate. So I use a negative, 0.6 meters per second squared. She says she moves now after she throws it, and when she moves to the left, 0.6 meters per second squared. Meters per second. Okay, so what I have here, 8 times 4, right? 8 times 4 is, gosh, my brain is fried. Should be 32. Okay, great. So I have 32, ends up with minus 0.6 m2, and that's still 0. So it ends up with being 0.6 m2 equals to 32 divided by 0.6. Okay, divide both sides by 0.6, cross out, and therefore m2, which is the mass of the girl and roller skates, is equal to 53.33. 33. Okay, so therefore I come on the side here, the mass of the girl is going to equal 53,33 minus 2 kilograms, because if I go back to my question, the total mass of the roller skates is 2 kilograms, and I only want the mass of the girl. And therefore that is equal to 51,33 kilograms. Question 4.4 says, now calculate the magnitude of the impulse that the girl roller skate combination is experiencing while the parcel is being thrown. Okay, well, we know the formula for impulse. We know that F net times delta t is equal to the change in momentum, and we know that this part here is of course equal to impulse. So therefore our formula will be written as impulse is equal to the change in momentum, which is equal to, of course, mvf minus vi. We're only dealing with one object here, and that is the girl roller skate combination. Okay, so that's our mass, is the girl roller skate combination. So we know that the girl roller skate combination was 53,33. Okay, we don't have to write 51,33 plus 2. Okay, we could just add it in immediately there. Okay, the final velocity of the girl was negative 0,6, because she started from rest and then she moved to the left, so that negative indicates the direction that she moved, and it was to the left. Okay, and initially she was 0. Okay, so you're going to end up with 53,33 times negative 0,6, which gives us an answer of minus 32, back to where we started, newtons per second. Or you could have said minus 32 kilograms per meters per second. All right, impulse. We can't leave it, or we don't leave it like that. So we'd say, therefore, the magnitude of impulse. This is just one of the ways we can state our final answer, because we don't want to leave it as negative. Is 32 newtons per second, and we see it's negative, so it's in favor of direction to the left. So the impulse goes with the girl in the same direction to the left. Okay, add direction there. Okay, or we can say 32 kilograms per meters per second. It's up to you, doesn't really matter. 4.5, without any further calculation, you are not to perform a calculation in your answer. Write down the change in momentum experienced by the parcel while it's being thrown. Would anybody like to shed light on 4.5? Also, it's not a trick question. Somebody, 4.5. The magnitude, the change in momentum of the parcel. I'll give you a clue. We've answered it already. Oh, actually, you beauty. All right, the answer is 32 kilograms per meters per second to the right. Full stop, 2 marks, done. Excellent. Good job. This was a very, very nice question of momentum and impulse. It was asked quite nicely from the norm. Normally it's asked quite boring, using just a bullet and a block. And I've seen the bullet block system asked too many times. This is quite a nice one, a little different flavor on it, a little different spin, you know? So this is quite a nice question. I quite enjoyed this question when I used it in 2019. I used it last year as well for some of my students. So yes, great question. And I think we fared very well as a class, since we did this a month ago in well, actually we did it a while ago, about 2 months ago. We're in April now. We started it in January, and we did it throughout the first week of Feb as well. So I'm quite happy where we fared on this question. Okay, cool. What I'm going to do now is I'm just going to get the paper 2 out. I think I have paper 2 of the same here. And we're going to get wired up for organic chemistry. Okay. For the next part, we're going to do organic chemistry. Okay, so started with question 2. We can motor through question 2 quite quickly for 13 minutes. And then we'll run through question 4, which is reactions, quickly. And no, that's a different section. So question 2 and question 4 we'll aim to do. Okay, so we'll start question 2 as a nice warm-up. Question 2 is usually they usually sometimes give like a table of options of A to F or A to E. This one, question 2, this year they haven't done it. But basically the question is we got to study the structural formula below. Can anybody tell me 2.1.1, what homology series is it? To which group?
Ester.
Thank you. Excellent. Very good eye there. All right. And I'm sure most of you got that as well, would have noticed that it was an ester. Okay. Beautiful, sweet smelling fragrance. Gives off a sweet smell. That's what esters do. Okay. Awesome. Okay. So let's answer the rest of this question up until 2.3. We'll mark it and then we'll answer, up until 2.2, because 2.3 you can't see. We'll do 2.3 and then we'll finish off with question 4. Okay, let's go. Right, so for 2.1, we already answered the question. Sorry, there's someone mentioning something to me. Yes, Matthew.
Could I just quickly see 2.3? Just quickly.
Sure.
Okay, thank you.
You're welcome. Okay, should I leave it up or?
No, it's fine. I took a screenshot.
Okay, cool. Sweet. Okay. Okay, so we already answered 2.1.1, which homology series it belongs to. We've established that it is an ester. Now 2.1.2 is the IUPAC name. Okay. So this is November 2017, paper 2. This is for grade 12. All right. So 2.1.2. Okay, the IPAC name. Okay, so let's just pay attention to one thing quickly. How we name an ester is everything. Okay, it's highlighting everything now. Okay, so all the carbon chain where the double bond oxygen starts, that's going to obviously be the main or the second part of the name, IPAC name, and the carbon chain before the single bond oxygen is basically going to start, that's obviously where you start naming your ester from. So we got 2 carbons bonded onto 1 oxygen, and then on this side, and then obviously the main carbon chain on the right, or to the right of it. So 1 carbon, 1 CH3 bonded to CH2, so we know that's an ethyl. Okay, ethyl or ethyl. Okay, and then we count the carbons after that with the double bond from the double bond oxygen. 1, 2, 3, 4. So we obviously know that the suffix of an ester is O8, and 4 carbons would be, if it was an alkane, would be butane. So we put those together, ethyl, how do I spell that? Butanoate. There we go. Ethyl butanoate is the name of that ester. Okay. 2.1.3. Let's get some interaction here. Give the IPAC name of the organic acid used in its preparation. 1 mark. Anybody care to state the acid, the organic acid used?
Butanoic acid.
Excellent work there. Thank you very much. Butanoic acid. All right. Lovely stuff. 2.1.4. All right, now 2.1.4. For this compound, write down the structural formula of its straight chain, unbranched functional isomer. All right, I'll do this, of course. So, straight chain means, okay, carbon rules, right? In the above here, the structural formula there, that's not a straight chain because there's an oxygen in the middle. A straight carbon chain means there's nothing else bonded onto it. Okay, so a functional isomer, okay, or at least the something else bonded onto the carbon will be probably at the beginning or at the end of the chain. So 2,4, let's see. So it's ethyl butanoate. So there is a butanoic acid and ethanol we used. So we can just change that slightly and we can have a 6 carbon chain. 3, 4, 5, 6. Alright, I'll just fill in the branches ever so roughly. Don't do this in your exam, of course. And we'll add the double bond oxygen here and the hydroxyl group at the end here. And we just add in, if I add in the hydrogens now, it'll take too much time and I don't want to run out of time. So these are the blank spaces, obviously where your hydrogens go in. So I'm just stating that for everybody who's going to watch this recording later and for everybody in the classroom now. Okay? Functional isomer, we just changed the functional group. Okay? We changed it completely. Okay? So we have 1, 2, 3, 4, 5, 6. Yes. And what would we name this straight chain functional isomer of an ester? What would we name it? Anybody got a name? I mean, it's not part of the question. This is just me asking. Anybody got a name? What?
Sorry?
Would anybody care just to name it? The question was just to draw it. We've drawn it. We get our marks and we can walk away. But obviously, this is the functional group here. So,
is it hexanoic acid?
Hexanoic acid, yes. It would be hexanoic acid if we were asked to name it. Thanks, Aleja. Okay, that was my question. No, so that was my question. That wasn't the question for the question. Remember, the question just asked for the structural formula of its straight chain, unbranched. This is a branch. So unbranched functional isomer. There we go. We drew it. We answered the question. But obviously we changed the functional group of an ester to a carboxylic acid. So this would be, yes, hexanoic acid. I got confused now with the 6-sided and the 7-sided. I think 7 is hept. 5 is pent, yes, but 6 is hex. Yes, there we go. That is correct. Awesome work. Good job, my chicks. Okay, so that would be that question. Let's do 2.2 quickly. Write down the structural formula of 4-methyl pentane-2-one. Okay, 4-methyl pentane-2-one. Okay, so this is a ketone. Okay, so I have to draw this one for you guys. So pentane-2-one. So that is there we go. 1, 2. 3, 4, and 5. Okay. So they asked for the 4th. That's 4-methyl, I think, if I'm not mistaken. So it depends on how you want to draw it. I'm going to draw it like this. Okay. There's my methyl. Here's my functional group, double bond oxygen, and there's my hydrogens of my straight chain. So structure group 4-methyl pentane-2-one. Okay, so we're obviously counting from the side right to left. So pentane-2-one, okay, right to left. My double bond oxygen is on the 2nd carbon, and of course my methyl is on the 4th one. Okay, if you decided to draw it over here, I'm not sure. I think that would be incorrect, but this is most correct, of course, and what they'll be looking for. Functional group at the end for ketone and our methyl over here. So we're counting 1, 2, pentane-2-one, 3, 4 methyl. We've answered the question. Okay, lovely stuff. 2.3, consider the structural formula below. Okay, quite a nasty looking one here, almost. For this compound, write down the general formula of the homologous series to which it belongs to for 1 mark. Alright, and then 2.3.2, the IUPAC name. Okay, obviously we're focusing on the triple bond here, so that triple bond there should tell you exactly the story of which homologous series it belongs to. Okay, number 1. Okay, cool. So about 4 minutes, and we'll mark it. Okay, so I'll do 2.3.1 because that's a bit like simple, because we all should know the general formula of an alkyne. Okay, it is CnH2n minus 2. Okay, 2H2n minus 2. Okay, that should help you with 2.3.2, which asks for the IUPAC name. Okay, so let's have a look and see here. So let's try and count, because maybe we're trying to find a main chain here. So if I count the straight chain in the straight line, 1, 2, 3, 4, 5, 6, 7. If I count from here, 1, 2, 3, 4, 5, 6, 7. If I count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it's definitely 7, so we know it's definitely heptine of some sort. Alright? It's definitely heptine. Now we just got to decide the numbers now, for which way we're counting it. So if I count from 1, 2, 3, 4, if I count it from left to right, it's going to be 4. The triple bond is going to be on the 4th carbon, but if I count from right to left, it's going to be on the 3rd carbon. So I'm definitely going to count from right to left. Okay? Or even if I count from here. Okay? So let's see. Let's see. Okay, yeah, let's go. 1, 2. So if I count from right to left, 1, 2, I got a methyl on 2. 1, 2. 3 is my double bond. 4, 5. 5 looks like I got an ethyl. Yes, there's an ethyl here on 5. Okay, notice how it is structured or drawn. Notice, okay, usually an ethyl would be this H would be here and this would be on top. Still the same thing. Okay, so 5 I got an ethyl. Okay, and 6 I got another methyl. So I end up with 2. I got a 2, and on 6 I have a methyl, so that's dimethyl on 2 and 6. 5 I've got an ethyl, and my third on my 3rd carbon, counting from right to left, I have the triple bond, and I need to state on which carbon is the triple bond. So I start by saying with my branches, 5 ethyl dash 2,6 dash dimethyl. Dimethyl meaning that I have 2 of them. Dimethyl, and I can do this. I can do this one either one of 2 ways. Dimethyl hept 3-ine, or I could keep everything the same here, dimethyl up until here, which I'm going to use these quotes for to say that remains the same. And this last part, I can say after the dimethyl, I could put a hyphen 3 and another hyphen heptine. Okay, so that last part can change, but everything in the beginning before the hept stays the same. So 5 ethyl, 2,6 dimethyl, that stays the same. Okay, and that was the IUPAC name of this structural formula here, which looks quite nasty, to be honest. Looks quite nasty. So that, I can admit, would have probably costed quite a lot of people some marks. I mean, there's only 3, but I mean, it might have costed them some marks if you weren't careful. So just to go through the tips and tricks there, count, check your main chain, and establish what homology series it belongs to. Triple bond, it's an alkyne. Count all your carbons to check if there's a longer chain or not. Unfortunately, the main chain that stood out was a 7 carbon chain, so that's heptyne or hept, okay, as our prefix. And then we just had to start by naming it, okay. So my biggest branch there is the ethyl, so 5-ethyl, there's a methyl on 2 and 6, 2,6-dimethyl, and then obviously then I start naming the main carbon chain. Okay, any questions on question 2? Okay, question 4 is a nice question. States the flow diagram shows how an alcohol, which is compound P, okay, can be used to prepare other organic compounds. Okay, the letters A to E represent the different organic reactions, and X and Y and Z are organic compounds. Okay, so this is typical, all right, pretty standard. However, I'm focusing just on 4.1 for now. 4.1, is compound P primary, secondary, or tertiary alcohol? And let's give a reason for our answer. Okay, so this is a common question that is asked about alcohols. If alcohols appear in your test or exam, they'll ask, is it primary, secondary, or tertiary? Okay, so let's take a look at that. Let's first establish what is the name of the alcohol. So it definitely looks like, well, it's definitely, there's a 4 carbon chain there, so it's bute for 4, and it looks like butanol if I count where the functional group is. So it looks like butanol. Okay, I'm happy with that name, butanol. Cool. And is it primary, secondary, or tertiary? Anybody like to take a stab at that question, 4.1?
Secondary.
Secondary. Jalen, you are correct. But now you need to motivate your answer. Why are you correct?
The C in which the OH is attached is connected to 2 other C carbons.
Excellent. That's correct. 100%. Good job. Okay.
We were given this page today to practice on. So
Well done. Okay. Excellent. Your school is woke. Wow, do people even still say that anymore? My gosh. Forget about it. It is a secondary alcohol, but notice the explanation for why. The C atom, the carbon atom to which the OH is bonded to, so this carbon atom right here, okay, this little bad boy here, okay, is bonded to another 2 carbon atoms. Here they are. Okay, oh, there's 2 on either side. Okay, if it was a primary, how would it look? If it was a primary, it would be on the first one. So if this was at the end here, it would be primary, because we'd start counting from there to make the chain, obviously, or make the name a bit shorter. We wouldn't want to say butanol, but rather just butanol. Okay, if, of course, if it was still here and there was another carbon here, all right, so it was not butanol but pentanol, for example, there would be tertiary because it would be bonded to another 3 carbon atoms. Okay, that's a very good question, all right, and they love asking it. All right, they love asking it. Question 4.2. Unfortunately, I have about 2 minutes, so I'm going to have to squeeze in these 3 quickly. But question 4.2 is write down the type of elimination reaction represented by A. Beautiful question. They told you it was elimination. You just had to write which one. So we obviously have an hydroxyl group here, which is an alcohol. Then we go, reaction A happens, and we end up with an alkene as our major product. Okay? So what happened? We got rid of the hydroxyl group and another hydrogen. that would be, so in other words, if I take a dihydroxyl group, which is OH, plus another hydrogen away, I actually end up with an alkene plus H2O, because I've taken away water. So that would be dehydration. 4.2.2, the addition reaction represented by B. Well, that's just the opposite of A, hydration. Okay, so the reverse and forward reaction happens between A and B. And the last one, 4.2.3, the elimination reaction represented by D. Okay, so you first need to understand what happens with compound P before we get to compound X. So from compound P to compound X, we end up with an organic product. So it looks like we have the addition of a hydrohalogen. So that looks like hydrohalogenation. And then from compound X to compound D, we also get an alkene. So because compound P was hydrohalogenation, and we go to an alkene, that must be the opposite of this addition reaction that happened here. So what do we end up with? It's that answer, or that type of elimination is dehydrohalogenation. Quite a long name. Okay. And that concludes my session for this evening, grade 12s. Like I said, if you'd like to download this paper, you're welcome to download it straight off the World Wide Web, and you can practice the rest of question 4. And stay tuned for the next video. We will continue muscling through the next few topics.